Hello everybody. Today I have the pleasure to welcome you to our talk with the title Geologic Mapping of Planetary Bodies, short called GMAP, the current status, requirements and the plans of our new project. And I have the pleasure to present you these on behalf of my colleagues and the great team behind this. I think I don't have to say you what a geological map is about, because the most of you already know that a geological map is a planar representation of a territory from which the surface composition and the material properties, subsurfaces, structures and compositions are inferred. But because the most of us do not have the possibility to visit the great area in and around Flagstaff this year, I like to present at least a geological map of that region. This kind of geospatial information is a very valuable basis for further studies, for example, if new and higher resoluted data are available. The quality of a geological map result depends on the experience of the mappers and the availability of the database. If we now go from the geological map in general to geological map in planetary, we here have different kind of maps. On the one hand side, we have the base maps, which are data products on which unit and objects may identified, for example, via control mosaics or digital terrain models. Whereas within the geoscience maps, these units and objects are visualized and describe the geological context by structures, geomorphologic features, units, and stratigraphic areas. On the other hand side, we have the non-standardized maps, which are the maps published by venues like peer-reviewed journals, theses, special issues, and book chapters, whereas standardized maps are published by USGS that require adherence to cartographic standards, conventions, and principles. Up to date, only USGS has provided planetary geological maps on a regular basis, and no other permanent infrastructure in the world supports and integrates these valuable products with new innovations. In order to supplement this high-level process also on European level, to cover the aspects in planetary geological mapping and support robotic and human exploration, two projects already funded by the EU through Horizon 2020. The first project, called Planetary Mapping Project, short PlanMap, which aims to provide highly informative geological maps of Mars, Mercury and the Moon. This includes spectral information, element compositions, absolute ages and ground truth information derived by past and ongoing planetary missions. PlanMap serves with an important testbed for defining standards and procedures in order to improve geological mapping processes of planetary surfaces. Spectral enhanced maps, 3D geological models, virtual reality and for public dissemination comics are some of the innovative key points within PlanMap. Giving you a short impression of some PlanMap products, here a spectral enhanced map example is shown. This map combines the geomorphic units mapped in the Hokusai quadrangle of Mercury with spectral units for the same quadrangle in order to create a geostratigraphic unit map. And what the result could be, you can see on this poster presentation, and further information you can find via the link below. Or another example, what we see here is a short demonstration of the 3D geological models which are quite unexplored in planetary surfaces. In order to continue streamlining the processes which are involved in planetary and in production of geological and geomorphological planetary maps, a second project starts in spring 2020. The second project, called GMAP, this is short for Geologic Mapping of Planetary Bodies, and is together with other virtual access activities a part of the Europlanet 2024 research infrastructure. The aim within this project is that planetary scientists can produce a geological map or a derived higher level product through the GMAP environment with the help and the advice of the GMAP partner institutions, who will provide base maps and technical aid. This means we create a solid infrastructure to foster, support and sustain the production of planetary geological maps and related products following standards and procedures. The resultant maps will provide support for ongoing and future planetary missions, training activities and cutting-edge science achievements. Having a quick look into the environment that likes to cover by the Planetary Research infrastructure, one can say that it is established to deliver tools and services for geological mapping of any solar system body, and therefore the infrastructure activities are divided in three main parts: the networking activities, for example, the community support and training; the transnational access, for example, studies for planetary field analogs and laboratory facilities; and last but not least, the virtual access, which hosts projects like VESPER, machine learning activities, but also the GMAP project. Showing you a short overview of the structure of GMAP, I like to use this image. And what you can see here is that the whole structure is divided in two parts: the virtual access part and the joint research activity part. And what does it mean and which tasks are related to the parts, I will explain you right now. The task within the JRA part is the coordination of GMAP developments, maintaining the European and international connections. It is the definition of consolidated mapping standards for geological maps and related products, and the provision of base maps and pipelines for the geological mapping services delivered by GMAP. For example, the ADAM platform is a part of our base map making workflow, in that is provided access to reduced GeoTIFF versions of the PDS data on Mars, and further information you can find via the link below. Another development is MAPI, which is a QGIS plugin that simplifies some useful operations needed to create geological maps by the point and contract principles. And here also you can find further links on our GitHub page, where you can find the link, and the link you can find on this website. Within the virtual access part, mappers can have direct access to institutions specified in different fields of planetary geological mapping to obtain specific guidance on the base of the final product. The final products will be digitally delivered, and last but not least, the virtual access has to develop and has to follow a sustainability plan. One essential part within the virtual access is the community support, and within this we develop a web page collecting useful resources and information, free documentation and tutorial material. This is also a place to freely host and share your products. In order to understand the community needs, we are launching a monthly community meeting and a mailing list for all interested people. And so if some of you is interested too, we like to welcome you to indicate your interest via the mails you can find on that slide. One highlight this year was the PlanMap and GMAP Winter School. Here, within 1 week, a lot of instruction related to planetary mapping are given to the participants, and the accessible tools are demonstrated within the practical lessons. It is a great intention to establish this kind of educational event once a year. Once a map product is finished, a simple directory structure helps the user to locate and access the products. Here, one unique name is associated to the map and guide to the main directory. The name is divided in the project prefix, either PM for PlanMap or GM for GMAP, information about the target body, type of maps, additional substrings, and at the end, the versioning number of the map. Besides the already presented parts within the VA, only one further relevant and essential part of the community support is the newly created data portal. This is the platform where the participants can store their valuable map results in order to create a reusability for further needs. What you can see here are 3 map examples, what we already have on the data portal. You can see 2 maps from the Martian surface and 1 compositional map of Mercury. But further on, we do also have some other data sets, which are virtual reality data sets from Mars, from the crater Jezero, and also from the ExoMars landing site from Oxyaplanum. And another one is once again a morphologic stratigraphic map of the Martian surface. To sum up, I like to say that GMAP is the first funded effort to bring geological mapping into the European planetary research infrastructure. The exchanges with the community at workshops such as this one on Open Planetary is very effective. And as I already said, that we plan to have yearly schools and workshops in order to train new geological mapping community members. And with this last slide, I'd like to thank all of you for your attention, and that's all I have to say for the moment. And as I already said, if you are interested in launching a monthly community meeting or like to join the mailing list, please use the mail address to indicate your interest. And I hope we see us very soon, hopefully in person, in order to continue fruitful discussions about the creation and the reusability of all the valuable planetary map results. Thank you very much and hope to see you soon. Bye bye.